I think we'll just go ahead and get started. This is really an exciting topic for me because it's something I've thought about for literally for decades. This idea of creating a digital version, but it's an idea that seems to be coming to life in the world. So we'll talk about what's going on in terms of this concept and how it's being developed, and then maybe more importantly, how we, you and I, could actually do this on our own, and actually pretty inexpensively and quickly. So let's get going. So backstory on why I might be qualified to speculate about this topic. I have a lot of lean experience. I'll say that for starters. I've been doing this lean consulting gig for about 30 years. In fact, this year is a 30-year anniversary of when I became a full-time lean consultant. So I may not look it, but I've been doing this for a while, as President Biden said. Now, the thing is, the motivation for doing something like this is that even with the best of methodologies, the best of training and experience, lean projects or process improvement projects can go wrong. Maybe not fail, that might be too strong, but you don't get the results that you expected or wanted. And so building models is a classic. It's not new. It's a classic way of trying to address that, being able to test systems in an inexpensive and quick way before you actually do it, and then get disappointed later on. So it's kind of the idea of a wind tunnel, right? If you're building an aircraft, you want to have a wind tunnel, not to test the completed airplane, but test it in a model stage so you can make improvements at that level. Now, I did work for 2 years with the Quran Consulting Group in San Diego, California. And Quran Consulting Group, they're really one of the national, in the United States, leaders in simulation modeling. And they were the California or West Coast representatives for ProModel Corporation for a while. I don't know if they still are, I'm not sure. But I worked with them for 2 years, not as a simulation expert, but as their lean representative on the team. But I worked with those folks for 2 years and really developed a kind of a deep appreciation for that skill, that discipline. So I have that in my belt. And then following that, we created this product called the Lean Design Simulator, along with Jalal Kaplan from the Quran Consulting Group. So this is a lean manufacturing-oriented simulation modeling software that we've now included as part of our Lean Design Studio. So we'll be sharing a little bit about that. Now, this is sort of tangential, but my wife is an architect and she's a Revit user. And so I've noticed in my research on digital factories or virtual factories that Revit, which is a 3D modeling system used by architects, but a lot of other folks as well, is being used for this purpose as well, to create three-dimensional models. So I'm basically an AI, when we talk about AI now, I'm basically an AI user, maybe like you. I'm not an AI expert, but I have been using it quite a bit. And so I wanted to share, how we're integrating or how I've been using AI, primarily ChatGPT, but some other products like Claude AI to enhance my lean work and this whole concept of the virtual factory. So I think I have enough background to make a contribution here to this discussion. So let's define what we mean first by a virtual factory. So, or the other term that's often used is digital twin. So the idea is pretty simple. We have a physical factory, and the vision is that we create a digital version of that factory. Now, maybe the digital version happens first, right? Maybe we don't have a physical factory. Maybe we design a digital version first, and then we implement the physical factory. But in any case, the concept is we have two. We have a electronic, kind of like the Matrix version, and then we have an actual physical version. And the idea is to use it for a lot of things. I mean, we can use it to improve processes, right? We can use it to monitor performance. We can use it to, well, it's all listed here, enabling manufacturers to simulate, predict, and optimize processes without physically intervening in the actual production itself. That's an important aspect. So we can do experimentations, for example, what if scenarios, and try things out in a digital environment without having to impact the physical environment. And of course, if you don't have the factory yet, if you only have the digital, then this is a way of optimizing the design before you actually go and build it and avoid what we sometimes call Kaizen, but in many cases is often rework, right? Having to redo things because the actual physical performance didn't meet expectations. So that's the idea. So that's pretty easy to understand. And I think we're reaching the point in our technological advance that we can actually do this. Whereas before, it was a little bit harder. Now, one question I had, and maybe you have, is what's the difference between a digital twin and just a simulation model? Because simulation modeling is not necessarily that new. In fact, probably simulation modeling on a computer dates back to the 60s, 1960s, 70s. Certainly, when I went to business school in the early 1980s, so I'm dating myself again, we were using simulation tools. I remember one of the projects we had to work on was developing a simulation model of a ski area. And I live in Colorado, so that was an appropriate example. So this is not entirely new. So we have this simulation modeling, and there are a lot of software companies and software products that offer simulation modeling tools. And now we have this concept of a digital twin or virtual factory. So is this the same thing? Well, I guess my impression is that it is kind of the same thing, except that when we're talking about a digital twin, we're now talking about something that's more tightly integrated with the physical world. So we may have, in a digital twin, we may actually have sensors in the physical world that are feeding data in a real-time way to this digital twin. Or the digital twin is trying to incorporate more aspects of behavior and interaction than we do normally with a simulation model. And probably in a digital twin, we're trying to be more inclusive of everything that happens in that environment, in the physical environment, and include that in the digital twin. Whereas in simulation modeling, we tend to be more selective in terms of what it is we're choosing to model. But fundamentally, in my mind, they're very similar. It's just that the digital twin is really taking it to the next level, you might say. Okay, so with that understanding, one of the other questions I had was, well, if we're integrating real-time data into a digital twin, is it actually running at real time as opposed to simulation time? Because one of the advantages of simulation is that you can do scenarios and run the simulation model in much faster than actual time and run experiments much more quickly. So I guess the answer is I'm not entirely 100% sure, but I believe that the answer is it depends on what you want to use this digital twin for. So if you're using it so it's the use case, the point number 4 here on the slide. So what is the use case for this digital twin? And if your goal is to do real-time monitoring, right, or maybe predictive maintenance kinds of things, then it probably is running more in real time, right, where you're actually synchronizing the physical world with this digital model. However, simulation modeling in general is not really being used for that. It's being used for optimization, right, or experimentation, trying to compare various outcomes of a simulation model to what might happen in the physical world and predict what might happen in the physical world, but not running at real time, running at a much, much faster speed. So I think the digital twin probably could do both, most likely, right? Could run faster and run slower. It depends on what we're attempting to use it for. Now, who in this world is doing this? Who are actually building digital twins? My source in this case was just to do a search online to ask. And one of the places I was looking was YouTube, so I could probably not only get some text information, but actually see maybe some demonstrations, some videos and so on. And I discovered there's just a ton of stuff. I mean, there are a lot of people, either people offering the tools to do it or the companies actually building digital twins. It seems to be kind of taking off. And one of the more interesting videos that I can recommend to you from YouTube is, you could just do a search on this, BMW, and the title of this YouTube video was BMW Group Celebrates Opening the World's First Virtual Factory. Not first virtual factory in general, but using this NVIDIA Omniverse development tool, I guess. And this video was not, it's not old. It wasn't yesterday, but I think it was about 11 months old or so. And it's pretty interesting. And it describes how they developed this entire factory, including 3D animation, including people walking around and the whole thing. I guess using NVIDIA's development platform. But there are a lot of other people working with this. So virtual twin experience for manufacturing operations, Dassault Systems, which I believe is another platform, probably a competitor with NVIDIA Omniverse. How digital twin technology is used in manufacturing, Emulate 3D. So again, another software company, most likely developing, offering tools. And then the NVIDIA Omniverse, I'd looked into that in more detail. I'll share a little bit about that. And then actual companies, we have digital twins will be the backbone of industry in the future by Siemens. So Siemens, both of these companies, BMW and Siemens, are German companies. That may tell you something about who's interested in this initially. So Siemens is doing this as well, apparently. And you can watch some YouTube videos on that. And then Azure digital twins. So now Microsoft is getting into the game. So they're offering, again, probably a competitor to some of these other companies like NVIDIA, offering a platform to develop digital twins or virtual factories or virtual environments, not just factories. There are other opportunities for this that I saw online, like developing digital models of cities or schools or hospitals, or a lot of environments where you can actually apply this other than factories. So Microsoft is getting into the game as well. So there seems to be a lot of excitement, and it seems to be growing. Most of these videos are recent, within the last few months. So it's not a lot of old stuff. Now, you probably can't read this very easily on your screen. I just paste it in there just as a reminder, and you'll be able to download this webinar when we're done, and probably read it at your leisure a little more easily. But it apparently documents that NVIDIA has come out with this, well, what they say, it's a real-time simulation and collaboration platform for 3D design and world building, they call it. So BMW certainly, if you watch that video, has developed a whole world, meaning a factory, a car factory, using these tools. And they list here all the things that they can do. Physically accurate simulations, definitely 3D, universal scene descriptions, photorealistic rendering, that's for sure, AI-powered tools, etc. So it sounds like they're getting into this. So apparently NVIDIA is involved in this. In addition to making their famous chips, they're getting involved in this world to use their chips as well, right? So if you use their software, you really need their other products as well, probably, to be effective. So I won't spend too much time on this, but that's what's going on. And here's a picture of the BMW virtual factory, how it was developed. Again, this is just a screenshot from the video that they produced, but it shows all the different tools they were using, including Revit, by the way, the 3D modeling tool that my wife uses. So, and apparently their platform can really integrate all these different tools. And so it doesn't sound easy, but pretty amazing. Okay, so now let's get back to the real world. So just looking at these models, my definite impression is that the cost and the effort and the time to build the virtual factory the way they were showing it, the way they were showing off, is high. It has to be high. So building the BMW virtual factory must have been at least a multi-million-dollar project, right? With lots of people. They even show you some of the people in the video. So that's one thing. Then once you've built this model, the idea here is you're using it. So you also have the cost of maintaining it, right? Of maintaining all the sensors that are feeding data to it. So in theory, every machine that you have in the factory has some kind of sensor or data link that's going and connecting to your digital factory. So that's huge in itself, right? And that just, you can't just set it up and walk away. It requires maintenance and management. So that's another ongoing, pretty huge cost. So my question here is for you and for me is, all right, all that sounds great, but back here on Earth, can we get some benefit out of this idea of a virtual factory without spending millions of dollars and years, right, to develop it? And I think the answer is yes, right? So we're not going to get everything that the BMW factory model is going to give us, but we can get some really important, valuable information at a much simpler level and a much faster level in terms of development, and certainly cheaper level. So I'll rely on Taiichi Ono from Toyota, who said, use your brains, not your money. All right. So for the rest of this presentation, I'm going to be exploring this idea of a virtual factory, but in a way that maybe we can actually relate to and actually do and actually accomplish, if that's okay with you. And it's not going to have all the bells and whistles that we saw earlier, but I think we're going to get maybe 80% of the benefit out of it. So here's what we're going to propose here: the low-cost virtual factory, let's say. And I'm using, to develop this factory, I'm using a simulation software tool that we developed, that I helped develop with Karan Consulting Group, called the Lean Design Simulator. So the Lean Design Simulator is a discrete event simulation modeling software. And it's really designed for value stream design and optimization. So it doesn't do everything in the world that maybe a more full-featured simulation software package would do, but it does in the lean world, it does what we typically do, which is value stream design and improvement. So I'm going to be using that as an example, but keep in mind that there are lots of options here. So there are probably dozens of companies selling simulation software packages. The better known ones are ProModel is one of them, Simulate, Arena, Flex, what is it? Simflex. I think that's the name. There are a lot of them, and they all work basically the same way, but maybe some are easier to use, some have more features, less features. But we're using this one because it's really inexpensive and it's really geared to what we want to do. So it's a discrete event simulation engine, and another advantage of the Lean Design Simulator is we designed the data model building to be done in Excel. So we're already familiar with Excel, and also the analysis of the results of the simulation run are in Excel. So we've Excel on the front end, Excel on the back end, and then in the middle we have this black box, which is the Lean Design Simulator that does the simulation processing, right, and creates the output file. So the advantage of this is that the learning curve is really low. You have to learn how to fill out the Excel worksheets, right, to build the model. So that takes a little bit of learning, but not that much. And then we have to learn how to interpret the results. So with the Lean Design Simulator, you're not going to get 3D animation and be able to watch people walking through the factory. But what simulation professionals will say, it's kind of like an inside joke, is that the reason that they're developing the animation and seeing people and machines moving, little objects moving through the factory visually, is so that you can explain the simulation model to management. But if you're a lean professional or an engineer, really you're looking at the data, right? Looking at the numbers. So that's not entirely true. I mean, I think there's value in seeing things move, but with the Lean Design Simulator, we're looking at the data, right? We're inputting the data and we're analyzing the output data. So that's what you can expect. And here's an example of the data. So there are actually, to build the model, there are actually 6 worksheets, and this is just one of them. But basically, you have a series of columns, and the learning curve is just to understand what goes in each of these columns. So we have a flow, we have a station code, that's a workstation or machine code or name. a description of that, default machine times and labor times. We have a detailed labor time and machine time worksheet, but if that's not complete or you made a mistake, it'll rely on any numbers you put in here. How many operators at that station, what required secondary resources like people and maybe some conveyance equipment, maybe an AGV, etc. You can define those here. Units produced per each input unit. So 1 in, 1 out, or is it 1 in and you get 3, etc. You define that. Next location, where do I go next in terms of the flow? So we're defining the flow in this worksheet. So it's basically as simple as that, but there's 6 of them, so you need to learn that to build the model. Then we have the engine. As I said, the engine is in between. So what we do is we upload our Excel file to the engine, and it'll do a validation. You know, did you do everything right? Are you missing some data? Give you some error feedback if that's the case, and then it'll run. And how long does it take to run these models? Well, it depends on how big it is, but it's usually seconds, literally seconds. Like click, 1,000, 2,000, done. That's about how long it takes to run through these models. But if you have a huge one, it's going to be longer, but not that much longer. And then we get the output. And so the output we're looking at is something like this. We have actually 3 worksheets. This is just one of the 3, but it lists all the resources down to individual labor resources, operators, and capacity, and then entries. So how many units did that person or that machine or that workstation start working on? And then what percentage of that total simulation time was busy, meaning adding value or working? And what percent was waiting? What percent was blocked? What percent was moving, traveling? And what percent was idle? So the difference between waiting and idle is waiting is, hey, I want to do work. We have demand, but I don't have anything to work on. Whereas idle is, we have no demand, right? I have nothing to do and nothing potentially to do either. I'm just idle. So this is a subset. And what I did here in the example I'm going to be showing you is I took a bicycle factory that we developed the model for, and I used that as the kind of the base model, the base virtual factory. So I had a virtual factory, meaning a simulation model for a bicycle factory, and that's what we're using. So what I wanted to see here is this. Can we take this output data from our so-called virtual factory that we built and use it in a more real-time way, as opposed to using it, which we normally do, to help design a line and test it and debug it, etc. Can we use the virtual factory to manage the line on a day-to-day basis? And so we're getting closer to the idea of a digital twin. And I wanted to see if that was going to be possible and whether we could get useful information so that we don't just build a model, we design the line, and then we never use the model again. No, we're using it on a day-to-day, daily basis to help manage the line. Maybe not on a minute-to-minute basis, but at least on a daily basis, we're using it to determine our sequencing plans, to manage performance, to compare actual results with anticipated or simulation results and improve the process, either improve the model or improve the physical process itself. That's what we want to explore. And if we can do that, by the way, we can get, I think a lot of the benefit of a virtual factory or digital twin at a very low cost and very quickly. Okay, so AI systems tested. So I'm using AI to do part of this analysis. And I tried a number of different things, but what I settled on were 2 available platforms. One is Claude AI. I don't know if you've seen Claude, but they just came out with a new version 3. And I subscribe to some YouTube newsletters or podcasts that try to keep track of all the crazy developments in AI. And what they said when I saw just a few days ago was that the latest version of Claude AI is actually exceeding the performance of ChatGPT-4 in a number of areas. So it's actually very good. And its claim to fame before was that it could handle a lot more text. So you could upload files, a lot more information than ChatGPT. But now apparently the sophistication of the way it's performing is very similar to, or maybe better than in some cases, ChatGPT-4, which was kind of the gold standard. So Claude can handle a lot of text. You can upload files and images. Seems to be a little better. This is just my subjective impression. A little bit better at math than ChatGPT, but not entirely sure about that. They both seem to have struggle. They struggle a little bit with math, and it seemed to do a good job at understanding the input, the simulation output file that I gave it. Seemed to be a good job at understanding that. So I'm pretty pleased with Claude. Now, ChatGPT 4, kind of the gold standard, allows you to upload, same thing. You can upload the output file as a CSV format, CSV. It's pretty much the market leader. It can also generate images, which Claude cannot, if you have a need for that. Claude, you can upload images to Claude, but Claude will not create images, whereas ChatGPT has DALL-E, I think, incorporated into it. And it did also a good job at understanding the simulation output, interpreting it, analyzing it, and offering it. So I think I can't declare a winner here necessarily, but one thing I've done is I had some conversations with both of these systems, and I created a file. Let's see if I can pop it up on the screen here. So I'm going to share this with you, and let's see. You should be able to see it, I think. Let me know in the chat if you can't see it. But what it is just simply a copy and paste of my dialogue with Claude and with ChatGPT regarding the output of the simulation model. I asked it to do some things. So you can, on your own time, you can review that document, which is kind of lengthy, and get some idea of the sophistication, really, of the AI systems. So I basically asked the two systems. I tried some other ones, by the way, and it got pretty good results. I'll take a detour here just to mention, I have on my local computer here in my office an AI system running called Jan, Jan, and it runs locally, but it's using these, I guess, the training databases. I'm not sure how it works, but basically I was able to download, and they gave you quite a few choices. Download the learning data and run AI on my local computer. So it's not running on NVIDIA chips or in some kind of big data center. It's running on my little humble HP Pavilion. It's a 1-year-old computer, so it's reasonably fast, but it's running here locally. And I went through the same exercise with it, and it did a pretty darn good job as well at analyzing simulation modeling output. So that's kind of interesting, right? I can hear when it's analyzing, the fan on my PC starts going up to high, because I know it's doing work, but it worked, and it was reasonably fast. So that's an interesting thing as well. So what I asked the AI systems, both of them, Claude and ChatGPT, to do is analyze the output file from the simulation modeling. And I gave it a little bit of help. I described what the column headings were in the report. And then I said, based on this description, tell me about it. Tell me what you see, basically. So I didn't give it a whole lot of guidance. And then I asked it, when it came back with some kind of impressions, I said, can you identify the main bottleneck resource in this specific model run? And then the third prompt was, what are the top 3 things we can do to improve the performance of the model, to make it improve throughput or improve utilization? And the answers I got were, well, I'll share with you here later on what it said, but it was actually pretty impressive, but there was room for improvement. But I think the room for improvement would be relatively easy to improve, because I didn't actually give it a whole lot of information to begin with. So if I'd done a more complete job of training the AI, I think we would have gotten better results. So here's basically the summary of findings that I had. And again, if you download the file that I gave you access to, you'll get a better, deeper understanding of of the conversation. But in general, and not to waste our time here, did it understand, when I explained it a little bit, did it understand the concept of a critical path? So this was important because you could have a lot of processes, but if those processes are not on the critical path, then improving them is not going to improve your throughput, right? So that's basic theory of constraints, Goldratt, theory of constraints, the goal, the book, The Goal. And so it would be important for us, AI to understand that concept. And when I explained it in a little bit more detail, the understanding from AI was actually pretty good. It understood, that idea that you could have a feeder line, but if that feeder line's not on the critical path, then it may have internal opportunities for improvement, but it's not going to improve your throughput of that line. So that was good. I was impressed with that level of sophistication, let's say, that it could understand that. Ability to identify improvement opportunities, good as you'll see, but I think, as I mentioned earlier, if I had a more complete script describing kind of the expectations and the goals and the methodology, et cetera, and maybe some more data. So I just gave it one worksheet of our output data. I could have given it all three, and I could have given it the input data, because AI had no idea of the processing times or the flow definitions or anything like that. So I think just having a more complete script describing the virtual factory to AI would generate much better results. I'll try to answer some of your questions. Like Antonio, I see you popped up a question. Let me get closer to the end of the webinar, and I'll try to address your questions. But let me get through this first. So I think, again, having a good, more complete script would get better results. So this is for future experimentation. Recommendations for people management. One of the things I said was, hey, in the short term, we can't actually change the factory, but we can manage our people much more easily. So do you have recommendations on managing people? And it came back with completely correct recommendations, but they were also very generic. So what I would be looking for would be more specific recommendations on where to move people, how to flex people more specifically, as opposed to a generalized recommendation. So again, I think a better script would get better results. So the future enhancements I would see for my virtual factory, for this experimentation I'm doing, is provide more access to the actual modeling data. I only gave it one simple worksheet. Give it access to the actual input data. So process flow descriptions, processing times, production sequence, and just more training on our side via the scripts that we would write, more complete ones. And apparently, I'm not sure about ChatGPT, but the new version of Claude can accept a lot of input. Like apparently you can upload like the entire Harry Potter series equivalent of text for it to process and analyze. So we can really create some, I think, I hope I'm right, but I think we can really develop some incredible and sophisticated models if we have better input, right? Better training for them. So again, download the script of the actual results if you want to see, how far we got with this. But I'm encouraged. I guess the bottom line is I'm encouraged by the results here. So what are we going to use this for? So here's the bottom line. Here's the grand finale. What I'd like to see is something like this. We start by building a virtual factory model. Again, Lean Design Simulator is what I use, but there are a lot of choices. And I'm not trying to steer you in the direction of the Lean Design Simulator. I'm just saying the learning curve is really low, but there's some great ones out there. As I mentioned, some of the brand names out there: ProModel, Simulate, FlexSim, Arena, et cetera, et cetera. Just do a search, a Google search, and you'll find lots of them, dozens. And some of them are just 2D, some of them are 3D, et cetera. Learning curve is going to vary. So based on that, then, once we have the model, we want to use that model plus AI to look at developing what we call sequencing rules. So if we're creating a production plan, we want to have some idea of what is the optimum order of production, because especially in a mixed model environment, which is our forte, it's our wheelhouse. In a mixed model environment, you're building different products down the same line that have different work content times, maybe some process variation, and it's not intuitively obvious, if that's how you're building products, what the right order is or sequence. What Toyota does at their fork truck factory is they try to apply what's called heijunka, or level loading. They're trying to even out the workflow, the work content flow from one model to the next by mixing. So one model might be harder, one might be easier. I don't want to put 2 or 3 hard ones back to back down the line, because what will happen is downstream from those machines, from those units, everything will start drying up because they'll be going faster. And upstream, everything will be blocked because those harder units are going slower. So can we even out the workflow? Again, the Japanese term is heijunka, by alternating a higher work content and lower work content product, so that combined together, they kind of equal or approximate takt time, the takt time. So takt time doesn't apply to an individual unit necessarily. Takt time applies to kind of like the average flow, because some are going to take longer and some are going to take shorter. That's the basic concept. So we need to develop some sequencing rules, and I would see that as part of our development phase. Now, when we get into daily management using the virtual factory, daily management of an assembly line, let's just say, as an example, could be any kind of value stream, but let's use assembly lines as an easy to understand example. What we want to do is analyze the backlog. So backlog could be our forecasted orders or planned orders, or it could be actual customer orders. Ideally, it's actual customer orders that we have in the queue, and we want to analyze those from the perspective of our sequencing rules, right? And develop an optimum plan so that we can deliver on time. I mean, that's important. So we have due dates, associated with these orders, but we also want to put them in the right sequence so that we can optimize our throughput, right? And not generate too much delay or waiting time or block time, in the production line. So based on our sequencing rules, we're going to create a production plan, drawing on our backlog or internal orders if we're using those. So we create a production plan. Now, what we want to do with our virtual factory is we want to run the plan through the virtual factory first. So we're going to run the plan with the model, okay? And then we're going to get results from running that model. Those results typically are pretty simple. The results are going to be, what was the throughput? Did we get the number of units that we want to get, in that day or in that week, whatever the time frame is? And then what is the utilization? Because you can get whatever throughput you want, but your utilization may be terrible, right? So you want to look at utilization of people and machines. So who's going to do that analysis? Well, if we have a well-trained AI, we should be able to feed that information electronically or with a file, like I did, to our AI analyst, let's say. And that AI analyst is trained in what to look for and can provide recommendations on how to improve that particular plan. And that plan is not a generic one. It's a specific plan, right, for that day or for that week, and provide recommendations on changing the sequence, adding more people, removing people to improve utilization, et cetera, all those kind of recommendations. Now, could we as humans do that? Yeah, probably. We do it. We do it today. But if we have a well-trained AI that's as smart as we are, or maybe in the future, maybe next week it'll be smarter, then we can rely on that to give us some ideas, some suggestions for improving. So you might have to go through this loop more than once, but what we're gonna end up with is an optimized production plan or dispatch list, right? That we can then release, right? Release to the floor to actually use in the real world. So I would see this as one of the things that, that would be fairly easy, I think, to implement, and it could be hugely beneficial. Because right now, when we go to factories and look at how these lines are running in many companies, there is a lot of delay. There's a lot of inefficiency and waste related to not understanding the subtleties of mixed model manufacturing. So I think there's great opportunity here to do that. And if we're using a tool like the Lean Design Simulator, then building the models, it becomes much easier, right? To actually create this little virtual factory becomes much easier. Now, is this going to give you everything you might want to have in terms of a full-blown digital twin? No. But it's going to give you some very important feedback and information that is, in my opinion, maybe a big part of the total potential benefit, right? Just by doing this. The 80-20 rule, in other words. Are we getting 80% of the potential benefit? Well, I don't know, but a big part of it in any case. So that's the vision that I wanted to share with you. Now, one last comment I wanted to make. If any of you watching this want to give this a try, I'd be willing to not do it for you, but I'd be willing to partner with you in terms of helping you set this up. Meaning we could provide the software, give you access to the Lean Design Simulator, because that's the one I know, and then work with you on all the steps of trying to make this happen. So it's like a free offer of help, because what I would like to see is some really robust case histories, with actual data, actual companies, and I don't have that yet. But if you're willing to give this a try, give me a call, right? Let me know, send me an email, and we can talk about it. We can set up a Zoom session and have a brainstorming session in terms of what you might have in mind. So I'm willing to offer my time, at least in terms of trying to get this to happen. Okay, so with that, that's all I wanted to share with you right now. You can download a copy of the presentation. Let's see, I'll make that available to you. So you should be able to download that as well. And a couple final reminders. We are in a partnership with Toyota, so they're letting us into their factory 4 times a year to use their facilities. They conduct the plant tours. They work with us. They engage with our students in terms of Q&As. It's really just a fabulous experience. And it's in one of the best factories in North America, especially for mixed model manufacturing. It's the fork truck factory in Columbus, Indiana. So it's just a life-changing experience. If your company is a mixed model style company, there's no better example, not just in how they run their factory itself, but their supply chain, their material management, material flow. It's just incredible. So the next one is coming up on April 30th to May 2nd, so it's 3 days. And then that's the material flow. So there's no better place. I don't think there's any better place in North America to learn about lean material flow or mixed model material flow than this place. And then in August 6th, we have the line design. So this is a workflow design. That's another 3-day class, same place, different subject. And then another material flow class at the end of the year, November 12th through the 14th. So if this is something of interest to you, just follow up on those links. This is a link to the information page, so you can get a complete idea of the agenda and what happens on each day and what will take place. But it's really, I don't think it's an exaggeration to say it's a life-changing experience. It'll stay with you forever. Very worthwhile investment. Okay, so that's it. So again, if you're interested in trying this out, give me a buzz. There's my email address. Write it down. Let me know, and we can set up a Zoom session. All right. Now, I think if you have any questions, we have a little bit of time that we could address them. So Antonio asked me, I was wondering if your black box, the Lean Design Simulator, can digest or process quality, uptime, and changeover data to get closer to the BSM concept. Quality, I'm not sure what you mean by that. We can integrate rework processes, like you can make assumptions in terms of X% are going to fail and go into a rework loop or leave the system. So you can do it that way. If you have some ideas of yield, or rework, if you have a rework loop, you can define that, certainly. And then uptime, uptime's a big output, because uptime, if you're talking about just efficiency, uptime is something you measure. If uptime, you mean equipment failure, so percent of good production. So you can factor in, as I said, Antonio, rework and scrap into the model. Uptime meaning equipment failure. I don't think there's too much to do there. There might be some workaround. I can't think of it offhand right now. And certainly changeover, yes. So if you're building, say, small quantities of the same product, and then you have to change over a machine, that can be built in two ways. It allows you to establish an average changeover time, and it also there's a way of defining variable changeover time depending on the lot size or the model. So the answer to that is yes. You can handle those kind of things. All right. Any other questions from the group you want me to address? Type it in the chat. I'll also, okay, so you have 2 files you can get access to, correct? All right, so if no other questions, I can let you go. And thanks for showing up. Oh, in Q&A. Sorry, there we go. Antonio, 2 more questions, good. Antonio, would building a virtual factory in the moon be feasible? In the moon. Do you mean La Luna? Or what is the moon? Can you clarify your question, Antonio? Building a virtual factory on the moon? Or maybe you meant some other word. Is the virtual factory process that you are developing, how are you taking equipment OEE into the plan? So you would have to build some assumptions about OEE into your processing times. So you'd have to have some factor included in the processing times to accommodate that. On the moon, you could build a virtual factory on the moon. You just have trouble doing the real one. So OEE can be, it's a little bit of a workaround. It's not an actual parameter you would enter. You would have to work around with some assumptions in terms of processing times, I think, to add that kind of inefficiency. Okay, Valentin, great. I'd like to see a visual example of the software. I do not have something on YouTube. Do you have something on YouTube? No, I do not. And it's not something we sell, by the way. We're not selling the Lean Design Simulator. It's a part of our Lean Design Studio, which is our platform for mixed model manufacturing. So it's not commercially available. It's available as a member of the Lean Design Studio, basically. So if you type in leandesignstudio.com, you'll see some information on it. And if you want to see more, I can send you an example of the data file, for example. But there's not much to see because the input is Excel, and then there's the black box where you just input runtime and warm-up time and maybe one other parameter, and then you analyze the output in Excel. I can send you examples of the Excel input and output if you want to see that, Valentin. But other than that, there's not too much else to see. It's all data-driven rather than visual. All right? Very good. Thank you. Anything else? All right. Okay. So I guess, Jean-Pierre, thank you so much. We'll let you all go and look forward to seeing you next time.